What's up, BMS? How are you doing today? I'm doing good. So today we are going to learn about humidity. Okay. So first things first, let me remind you that you should be doing your Go Formative daily essential work, and probably be easier to just do like per day instead of trying to do it all. I saw some students trying to do it all on Monday or Tuesday, and that's fine, but it's easier if you just do a little bit at a time, not so much work all piled in one. So remember, you've got work over on GoFormative daily and be checking Google Classroom each day. So, because there's like this is on Google Classroom. So, anyways, today we're going to be talking about humidity, and later in the week, Mr. Cook is going to post uh, probably tomorrow a phenomenon video on dew point, and then he's going to do a teach video on that. So today we're talking. Remember, we're in our weather unit. We're talking about humidity today. So if you remember, we did the phenomenon yesterday. Hopefully you went and watched that video. We're going to talk about that a little bit later in this video. So the first thing, so let's cover what is humidity. Humidity, a lot of times you hear that people talking, it's very humid outside. That just means that there is moisture in the air. So humidity is a measure of the amount of water vapor in the air. Okay, the amount of water vapor in the air. Okay, like on the Weather Channel, you hear what is the relative humidity. So they put that in a percentage. So you might say, well, it's 80% humidity. That means in a certain amount of airspace, it's filled up 80%. Okay, in that amount of airspace. So the more percentage you have humidity, that means there's more water vapor in that certain space of air. So two important things to understand about humidity. Number one, the ability to hold water vapor depends on its temperature. So when temperature changes, okay, that is when the airspace actually either expands or contracts. Okay, when it gets cooler, air actually tends to contract. When it's heated, it actually expands. So that helps us with the second important thing, which says warm air can hold more water vapor than cool air. Okay, so warmer air is going to be able to hold more. Talking about water vapor than cool areas. Okay, so let's talk a little bit more about the phenomenon that we did yesterday in the video. If you did not watch that, there's the link right here. You can pause this and go watch it. You should have already watched it and done some observations what happened. And what I did in that video is I had a time lapse, just super simple to do at home. Hopefully you did that with me. Took some ice water, put it in a dry cup, and then eventually about 10 minutes later, you'll see a lot of condensation forming on the outside of that cup. Okay. Now, what we found out, or what we're finding out now, and I found this little model here. It's exactly what we did. We put ice water in the cup, okay, and we saw condensation form on the outside. Now, that water came from not the inside of the cup, but it came from the moisture that was in the air around the cup. The only place for it to cling to is the side of the cup where it's the coldest. So the air inside, and that's what this little paragraph says right here. It says, remember that cooler air can't hold. I wonder what happens when I put this up here. Oh, yeah, that's a lot better. Okay, it says, remember that cooler air can't hold water vapor as well as warmer air. So we decrease the temperature inside the cup, okay, with ice water. This cooled the air around the cup, and the moisture in the air formed on the outside of the cup. So that's exactly what happened. Okay, it cooled the air around the outside. The air actually contracted and it shrunk. Okay, and what did it leave over? It left the moisture that was in the air. It condensed and turned into liquid. Okay, so it goes from a gaseous state to a liquid state. So it's a change of state. Okay, that was the phenomenon that you watched in this video. So the next thing, so how does this relate to weather? So let's pull this information all together. Okay, so it says here, let's read this. It says, for there to be precipitation, okay, remember that is like rainfall, snow, hail, freezing rain, all that stuff. Okay, for there to be precipitation, like rain, condensation first has to occur. That is cloud formation. Okay, you can't have rain, well, without a cloud. Okay, but you just can't because it's got to condense before it rains. Usually this happens above us, okay, in the top of the troposphere, which is the lower layer of the atmosphere. This happens above us where it's cooler. So it's kind of like where it was right next to the cup. Okay, if you go up into the top of the troposphere, temperatures actually decrease and they go down. So the higher you go up, the lower the temperatures go. That's why clouds form at the top of the troposphere. Okay, now it says if there is moisture in the air, there's got to be moisture in the air for it to condense. That's where we get clouds. You know there's moisture in the air if there's cloud coverage. Okay, if there's moisture in the air, then that moisture will condense and form clouds. This happens due to the warm air being pushed upwards where it was cooler. So let me take one of the fronts that you learned about last week. Cold front, okay? You've got a cold air mass that comes in. There's the front line, which is just the leading edge of the cold air mass. Comes in contact with the warm air, and guess what it's going to do? It's less dense. The cold air mass is more dense, so it's going to sink underneath, and it's going to push that warm air up. Well, guess what happens when that warm air is pushed up? Only if there's moisture in the air, there's going to be clouds that form. This would be considered the top of the troposphere where those clouds are. And since there's clouds, we know that there's moisture in the air. So that warm air gets pushed up, it starts to cool. So the air starts to actually almost like it shrinks or contracts. The opposite of expanding, okay, contracts. And what it begins to happen, there's water left over, okay? And when it becomes saturated enough, it'll condense as it cools, form clouds, and when it becomes heavy enough, it will fall down as a form of precipitation. Now, for us in Arkansas, if you see this right here, okay, this map of North America, we get the reason we have a lot of rain, okay, rained over Easter weekend, is the reason we get a lot of rain here in Arkansas is because if you remember, we talked about source regions too last week. Mr. Cook taught on it. Okay, it was at the beginning of that slides presentation of those videos. We get a lot of our warm air. Most of it we get from the Gulf of Mexico. So if you go south of Arkansas, that's where we get a lot of our air. And guess where that air came from? It came from over the ocean. Okay, it came from over the ocean. It's called maritime tropical. So we got warm air from there, and the air is humid, which means it has moisture in it. So if that comes in contact, let's say with this continental polar dry air, that cold air is going to come down, and we know it moves from west to east, west being over here by California, east being in this direction. If it moves in this direction, comes in contact with a warm, humid air mass from the Gulf of Mexico, that's called MT, maritime tropical, then that air is going to rise. It's going to create clouds, then precipitation. So for there to be, okay, weather, and when we're talking about weather like precipitation and cloud coverage, there has to be moisture in the air. Okay, so after this video, the next few days, you're going to see what Mr. Cook's going to call or talk about dew point. Okay, if you go outside in the morning, a lot of times, even in the middle of the summer, when it's hot during the day, there's moisture in the air. At night, those temperatures drop at surface level where we're at. Well, the only thing for that water to do that's in the air, that humidity, is to condense close to the ground. And guess where the only place it can land and cling to? The grass surface. And that's where we get dew, or dew on your vehicles or on the concrete. So most of the time it absorbs in the concrete, but that's where you get dew. So he's going to elaborate on dew point. But anyways, I'll let him do that. So I hope you have a good day. This is Humidity.